Okay, so this is question 15b that I'm going to go through here. So I've just, because I want to get it all on one screen, I've copied down the question from 15b. Oh, there it is, over here, just so you can see everything all together. So we're not going through A, we're going to go through B. So the question says the student warms HCHO and acidified potassium manganate. So they're the chemicals we're starting with. So what we want to do is circle them on our half equations so we know what it is we're starting with. So we've got our HCHO and our acidified manganate. So this is what we're starting with. Now what a lot of people did in the exam is just started off by doing an equation with HCOOH. But we don't start with that, and you can't do reactions with chemicals you don't have. So the first equation has to be between these two sets of chemicals, right? As they're the only things you've got. So let's have a look what's going to happen. So when two half cells react, when two redox systems react, which is the one that gets oxidized? Have a little think. This is the most important fact to remember. Okay, it's always the more negative one. So the half cell with the more negative electrode potential is always the one that gets oxidized. Now, if we actually read on in the question, it does say, explain in terms of electrode potentials what's going to happen. So let's do this first equation then. As my redox system 2 is more negative, it will be oxidized, so go backwards. As redox system 4 is more positive, it will be reduced, so go forwards. So let's write those out then. I've got HCHO plus H2O goes to HCOOH, 2H plus and 2 electrons. I've just written that out backwards. And then moving this one forwards, I've got my manganate, an 8H plus and 5 electrons. Goes to Mn2 plus and 4H2O. Next, we need to balance our electrons. So I've got 2 electrons there, so I'm going to multiply this bottom equation by 2. So this might get a little bit messy now, but 2, 16, the electrons will go to 10, 2, and 8. I had 5 electrons to begin with, so I multiply the top by 5. So 5, 5, 5. That'll go to 10 and 10. Next we cancel, so the electrons should always cancel as you've just balanced them, but also check if something else will cancel, and your key suspects are water, H plus and OH minus. So you can see on my reactant side I've got 16H plus, on my product side I've got 10, that will cancel to leave me with 6H plus. On my reactant side, I've got 5H2O. On my product side, I've got 8H2O. That will cancel to leave me with 3H2O. And then very finally, write it nice and neat for the examiner. So 5HCHO plus 2 manganate plus the 6 remaining H plus will go to 5 of the carboxylic acid, 2Mn2 plus, and if I can squeeze it on, 3H2O. So that's our first equation, because the question says include overall equations. Now there's a clue there because it uses a plural. So if we're reading the question carefully, we'll realise that we need to do more than one. However, it did say explain this in terms of electrode potentials. So why is it that this reaction happened? Well, we already said it's because redox system 2 has the more negative electrode potential and therefore will be oxidized. So we'll say, where does that affect? Redox system 2, which is the HCOOH to HCHO, has the more negative electrode potential, I'm abbreviating a little bit, therefore is oxidized. You could also say is the more powerful reducing agent. That would be another way of saying that, because the thing that is oxidized is the reducing agent. So whichever one you want to say. So let's keep track of what chemicals we've now made. By going backwards here, we've got some H pluses and some carboxylic acid. By going forward here, we've got some manganate and some water, but it's all aqueous anyway, so whatever. So notice we have now made some carboxylic acid. So this carboxylic acid here, look, that is that carboxylic acid there. So now, only after doing this first equation can we start doing stuff with the carboxylic acid, because we've now made it. So can you see the importance of circling what chemicals you have on your half equations? It lets you know what you can play around with. Yeah, this silver one, it ain't getting involved at all, because at no point have we introduced any silver. Okay, really nice tip. So now we've got our carboxylic acid. So what's going to happen here? Well, again, we're going to get one of them oxidized, one of them reduced. And the clue is that we observe gas bubbles. That should tell you what you're going to make, because that's the only gas there. So take a little second, have a little think then. Try this on your own, take a minute. Write out those two one-way arrow equations. Balance the electrons, cancel and combine. I'm going to give you 2 minutes to do that. Okay, so while she was doing that, I just wrote them out in the correct direction. As redox system 1 has the more negative electrode potential, it will be oxidized. And again, the manganate is going to be reduced, it's going to go forward. So I just wrote those out one way. Just like before, we're going to balance the electrons. So I need to multiply the bottom one by 2 again. So that'll give me 16 and 10, 2 and 8. I need to multiply the top one by 5 again. So 5, 5, 10 and 10. Just like before, we're going to cancel. The electrons will always cancel. That'll cancel to give you 6H plus. Nothing's going to cancel the waters now, is it? The waters are going to stay there because there is no waters as reactants. And then just rewrite it nice and neat for the examiner. So 2 manganate plus 5 of the carboxylic acid plus the remaining 6H plus will go to 5 CO2, 2 manganates, and the 8 H2O. So have we answered the question? Well, not quite, because it also said to explain what's going on in terms of equilibria. So just thinking about this first equation, if we think about, you can explain it by talking about either redox system. I'm going to talk about redox system 2, because remember this first equation was a combination of redox system 2 and 4, wasn't it? In redox system 2, which direction was the position of equilibrium shifting? Did it shift to the left or did it shift to the right? Well, clearly, if we're getting oxidation, then the position of equilibrium is shifting to the left. So we're also just going to want to put a little, I'm kind of running out of space, but a little sentence, I'll write it here. In redox system 1, sorry, 2 it was, redox system 2, which was the acid to aldehyde one, the position of equilibrium shifted left. We could have said in redox system 4, the position of equilibrium shifted right. Okay, and I've abbreviated, don't do that in a real exam, I've just run out of space, but do use the full words in an exam. So it looks like a lot there, just for 4 marks. Where are your marks going to be? We've got our 2 balanced equations, 1, 2. We've got our explanation in terms of electrode potentials. So redox system 2 as the more negative electrode potential, therefore was oxidized, or was the reducing agent. And then we've got our explanation in terms of the position shifting to the left.